Alright, 8th grade, here we go. We're talking about other area calculations. So we've already talked about circles and other rectangular figures and how we need to split them up sometimes, but we also need to review some of our other favorite quadrilaterals and also triangles. So the first thing we want to do is talk about derivations, and derivations is just like if you have a formula or we have a standard way of doing something, where does it come from? We don't want to just memorize tricks, we want to know why these things make sense. So the first one I want to talk about is the parallelogram. That's kind of the most basic. And we're going to talk about the parallelogram, it having an area equal to the base times the height. And this is confusing for some people because they'll often see a measurement given for the side length, and they'll think that that's useful, but it's not. And the reason is this, is because when we look at something like a parallelogram, what we need to remind ourselves of is a rectangle, and think if we take this little triangle area here and we move it over here, man, this is difficult, I'm sorry, and we move it over here, we canceled it out on this side and we moved it to the far right. Now we just have a regular rectangle. Now the way we find the area of a rectangle though is we still use this base up here. This length hasn't changed, but now we need to make sure that we usually think of rectangles as length times width, that we're using the width that just goes perpendicularly or at a right angle from the bottom to the top, from one base to the other. And this 7 meters that I give you over here, that does not, that's a diagonal, it doesn't go perpendicular. Another one we want to talk about is triangles, and there's a similar derivation that comes here, and the idea is this. We're going to say that for triangles, the first thing you want to do is consider, well, what if I doubled the area and then put these together? What do we have? Well, that should look like a parallelogram, because it is. It has two sets of parallel sides. Now, the area of a triangle isn't just the base times the height. That would give us the area of this whole parallelogram. The area of a triangle is half the base times the height, because the base times the height would give you too much area. It would give you the area of two triangles. We want just the area of one triangle. That's why it's 1/2 the base times the height. Now this last one is the most confusing or hardest to remember formula, but it's really interesting where it comes from, this derivation, and it's really similar to where the triangle comes from. And here's the idea right here. If you double the area of the trapezoid, you have a parallelogram. And what is the area of this parallelogram? Well, we know that the area of the trapezoid, one trapezoid, is going to be half of this. So we know that the area of one of the trapezoids is going to be half whatever the area of this parallelogram is, because we doubled it. So it's 1/2, and we know that the area of a parallelogram is the base times the height. So we're going to do the base times the height. But what is the base of this new parallelogram we made? Well, the base is made up of this base 1, and when we made that second parallelogram, we matched up base 2 with base 1, and we matched up base 1 with base 2. So to find the area of this parallelogram, we have to add base 1 plus base 2, the top and bottom bases, the two parallel sides of the trapezoid. We have to add those before we multiply times the height. And then again, we're multiplying by 1/2 because the trapezoid just makes up half of this monstrous figure. So those are some derivations. Hopefully those made a little bit of sense. If you're more of an equation or formula memorizer, then here we go. These are the notes everyone has to have. Area is still measured in square units, just like in our last video. A height is always perpendicular or at a right angle to the base. So we should be familiar with right angles, and heights don't go at the diagonal. Heights are always the perpendicular or the right angled measurement. Now the area calculation formulas, which we just talked about, are that the area of a parallelogram is the base times the height, not side times side. Area of a triangle is 1/2 the base times the height, again because we had to use two triangles to make that parallelogram. And the area of a trapezoid is 1/2 times the sum of base 1 and base 2, add the two parallel sides, and then multiply by the height. Alright, let's see what it looks like in action. If we're given this parallelogram, how are we going to find the area? Well, we know that area of a parallelogram, and I like to use this little symbol to show I know I'm talking about a parallelogram, is equal to the base times the height. The base in this case is whatever has a perpendicular coming from it, and we see this is the perpendicular. So the perpendicular is coming from the base 13 meters. And then our height is 4.5 meters. And you might be saying, well, what about that 6 meters? That is not the base because the perpendicular isn't coming at a right angle from it. And it's also not the height, it's a diagonal. So again, imagine taking this little triangle and putting it on the other side. Now we see why we have this rectangle. Let's multiply 13. Oh, now there are two ways to do this. Oftentimes we think about multiplying mixed numbers and fractions, and we think we have to create improper fractions. That's usually true, but we can also just use our number sense here and say, well, we're going to have 4.5 groups of 13. So 4 times 13, well, 2 times 13 is 26. So 4 times 13 would be 52. And we also had to add another half of 13. And half of 13, well, half of 12 is 6. And we need to get that extra one to go from 12 to 13. We'll need a half. So 52 plus 6.5 is going to equal 58.5 meters squared, or square meters. So hopefully you see that we got a base and a height, and hopefully that made sense. We're going to multiply 13 times 4.5, and that's kind of the distributive property, or that is the distributive property. We kind of said 13 times 4.5 is the same as 13 times 4 plus 1/2, and we distributed and multiplied by those separately, which is always a fair and good move. Alright, so hopefully that one made sense. You gotta have that copied down with me, please. The next one, let's see it. Find the area of a triangle with a base of 6 feet, a height of 16 feet, and other sides of 22 and 25 feet. Alright, we could draw this out. That might help. We could say that the base, oh, I wish this would work. They said that the base is 6 feet. Oh, so it should have been really short. Whoops. These are so wonky. Sorry. 6 feet, height of 16, and then the other two are 22 and 25. Goodness gracious. Height of 16 feet, and the other two sides are 22 and 25 feet. Now the thing about this is we don't even need those other two sides, and you might have thought about that as soon as you were reading the question, but hopefully you're just thinking that the area of a triangle, and I'm going to use my little notation again, area of a triangle is equal to 1/2 the base times the height, because it would take two triangles to make that parallelogram. That's base times height. The base they gave us is 6 feet, and the height was 16. 1/2 the base times the height. I'll multiply by 1/2 first because that's easy to do. Half of 16, let's do that. And this is the commutative property of multiplication. Half of 16 is 8, and 8 times 6 is 48. So this is going to be 48 feet squared, or square feet. So if you wanted to draw the picture, that's fine. If you want to just memorize those formulas, you got to have them memorized and just plug in. That works as well. Let's do one more together. Find the area of this, and this is a trapezoid. Trapezoid is the one with the longer formula, but that's okay. We love it all the same because it's kind of the most fun derivation. You have to be kind of creative to see that. So area of a trapezoid we said is 1/2, because remember we double it to find the parallelogram. Base times the height. But what's the base of the parallelogram we make? Remember we join up the long side and the short side, so it's base 1 plus base 2. So it's 1/2 b1 plus b2. Oh, you can tell I'm getting frustrated with this writing utensil. 1/2 base 1 plus base 2. Well, those are the two sides that the perpendicular comes from. So 9 and 15. If we add those together, we get 24. 1/2 24, and our height is 5. 1/2 of 24 is 12. 12 times 5 is 60. So this is going to be 60 feet squared. So for these types of problems, the assignment I'm going to have you do with these, and any quizzing or whatnot in the future, any problems, you just got to have those formulas memorized. Hopefully being able to visualize where they come from helps, but you're going to have to commit those to memory, and you're going to have to use them using your notes right now for these two. A triangle has a base of 9 feet and a height of 2.5 feet. What is its area? And number 2 says, what is the area of that triangle? Let's make this first one a parallelogram, since I don't want you to do two triangle questions. So hopefully everyone got that, and best of luck.